Hi guys, good morning. I think we have so maybe today by this first and second sessions we might have the dates for this JE and NEET announced, guys. So possibly we'll be able to plan it better. So maybe tentatively we can have it like only when they announce we will probably know, but what they're saying is it could be in the month of June. So we may get some good amount of time, like even 1 month sort of a time might be there, but only when they finally announce it we'll come to know about it. But accordingly, so whatever the announcement comes, right, we'll have to plan it accordingly, like the available time, how do you face the chapters for preparation, how do you plan in terms of your revision of pending chapters. So that and all we'll be able to plan it better once we come to know about the dates. Okay, so anyway, today we have Ashad John. Hi. Yeah, so today we have alternating current, guys. It's a sort of straight topic in terms of the scoring. If you look at NEET perspective, right, we'll get questions which are typically in the range of NCERT purview, especially from the alternating current. If you look at JEE examination, right, we'll have extensions to that. Now when we say NCERT level, what we talk about is series circuits of inductor and capacitor, or inductor resistor, or capacitor and resistor, or all three. So we'll mainly look at what the series combinations. Rarely we'll get questions on the parallel combinations. Gayatri, hi. Yeah, so rarely we'll get questions on the parallel combination and complicated ones, but in JE you will be having those aspects also. So but from NEET perspective we'll be having straight simple kind of questions, guys. So we'll take a look at the questions. I'm sure you guys would have gone through the synopsis part of it. Okay, so we'll start with the questions, guys, like the way we do. I'll read the question and then we'll wait for some time, then we'll see through the answer. Okay, look at this question, guys. This is the first question. The output of a step down transformer. So what we have is an step down transformer. The output of that is measured to be 24 volt. What is the output of the step down transformer? Measured as 24 volt when connected to a 12 watt light bulb. The light bulb to which it is connected is what? 12 watts. The question is the value of peak current is. They're asking what is the value of the peak current. So we need to tell what is the peak current value. Shamil, yeah, hi. So we need to tell what is the peak current value. Look at this question, guys. This is a kind of straight question. What is given to us? The output of the step down transformer is given to us. How much it is given as? 24 volt. And the power is also given. What is the power? The power is given as what, guys? 12 watt. We need to find the peak current value. Let's see, if you can get the answer. What we need to find, guys? Peak current value. Peak current means what? We need to find the I naught value first. Okay, Trisha, you are saying D. Check it one more time. See, whenever in an AC circuit, right, if we simply say voltage or current, what does it represent? It represents what? It represents the RMS value, right? So whenever I say that the voltage is 24 volt, means what is it representing? It is representing the RMS value, correct? Now based on that, you just think about it. See, they are given the voltage, means what? This is the RMS voltage. So what is the formula we have? Ashar John, A. Okay, so that's the correct answer anyway. So what is the answer for this question, guys? The answer must be what? A. Look at it. No, what is the formula we have? VRMS into IRMS is equal to what? Power. I mean, we are talking about the just resistor circuit. If we have inductor or capacitor, then what we'll be having, we'll also have what? The power factor. But here just the resistor, right? VRMS into IRMS is equal to what? Power. Power is what? 12. VRMS value is what? 24. SI units we are dealing with. IRMS is equal to what? 12. Means IRMS value will be equal to what? 12 by 24, which is 1 by 2. That is the IRMS value. What they are asking, peak value. Remember, what is the relation? What is the relation between the two? The RMS value, right? What is the relation between the two? IRMS will be equal to what? What is the answer, guys? Root 2 times, or 1 by root 2 times of I naught, means I naught value will be equal to what? Root 2 into IRMS. Check it. So 1 by 2 into root 2 is equal to what? 1 by root 2. Check the answer, guys. What is the answer must be coming as? It must be coming as what? A. Okay. We'll go to the next question, guys. 1 must be equal to what? A. Okay. So look at this question. Which of the following combinations should be selected for better tuning of an LCR circuit used in communication? So they are giving specific values for what? Resistance, inductance and capacitance. We have to tell which of them will be selected for the better tuning of an LCR circuit. Better tuning means what, guys? The quality factor, so to say. I mean, so when do we say better tuning? The quality factor should be what? Maximum. So when the quality factor will be maximum, think about it. Where are we going to have the quality factor maximum? Second question, Trisha, you are saying C. Check the answer, guys. Second question. So we need to have what? Better tuning. Better tuning will come in which case? It will come in the case of resonance. That is where we will be able to get the better tuning. Okay. So check this, guys. So what is it? If you have the variation of power with respect to the frequency or the angular frequency, we'll have the maximum power. That is what we'll get at the resonance value omega naught. On either side we'll have the frequencies corresponding to half the maximum power. Okay, so this side omega 1, that side omega 2. The gap between them is what we call as bandwidth. So quality factor will be equal to what, guys? Omega naught, which is the resonant frequency, by bandwidth. That is the quality factor. Correct. So we must have what? The quality factor should be what? Maximum. That is when we'll have a better tuning. And what is the quality factor formula, guys? Quality factor, we have these derivations. Quality factor will be equal to what? Either VL by VR or VC by VR, because in resonance condition both will be what? Same. Both the values will be what, guys? Same. So which means what? Either it will be omega naught into L by R or 1 by omega naught into C into R. Resonance condition, what is omega naught value? 1 by root LC. So finally this is the formula we will be remembering, right? What is the quality factor formula, guys? 1 by R into root LC. So we have to see in which case the quality factor is maximum. So among the given options, right, what do we need to see? We need to see in which case the quality factor is what, guys? Maximum. What is the formula? 1 by R into, check others also, you just check it, guys. We must see in which case this term 1 by R into root L by C will be what? Maximum. That is when we will be having better tuning. So this question, we have to take each of these options, just go and substitute. Just go and substitute and check in which case we are getting the quality factor to be what? Maximum. Okay, guys. So check it. Second question, it must be what, guys? C. So whenever we have the LCR circuit which is tuned for better communication, right, guys, the quality factor should be what? Maximum. Okay. And remember the formula for the quality factor also. So quality factor formula is what? Resonant angular frequency omega naught by bandwidth. Bandwidth is what, guys? The difference in the angular frequency value between the half the maximum power values. This side will have 1, that side will have 1. That gap is, so omega 2 minus omega 1, right, is basically the bandwidth. So resonant frequency by bandwidth is what? Quality factor. Clear, guys? So others also check. It's a substitution kind of question, guys. We have to remember the quality factor formula. If you remember, it means we can answer it. Okay. We'll go to the next question, guys. Look at this one. To reduce the resonant frequency in LCR circuit with a generator, what must be the condition? We have 4 conditions here. What is the objective we are having? To reduce the resonant frequency. What is the objective we are having is to reduce the resonant frequency. What is the resonant angular frequency formula? Omega naught will be equal to what, guys? 1 by root LC. What is the omega naught value? 1 by root LC. That is the omega naught value, right? We want to reduce this. Under what condition we can reduce? That is the question. Check it, guys. Third question is a theoretical kind of question. We want to reduce what? Omega naught. Means 2 possibilities, right? How we can reduce omega naught? Either we will increase the L value or we will increase the C value, either of them. How we can reduce omega naught, guys? Either we increase the L value or we increase the C value. We have to just check the options given and conclude which of them will be suitable. Which of them will be suitable for basically what, guys? For reducing the resonant frequency. Yes, guys. Third question, any answers? Look at the first option, right? What is the first option? The generator frequency should be reduced. See, this is nothing to do with the generator frequency, right? The resonant frequency is dependent upon what? It is dependent upon the self-inductance value and the capacitance L and C, right? Look at option B. Another capacitor should be added in parallel to the first one. See, if you have, yeah, I think somebody is saying the answer, Akash, B. Yeah, third is what, guys? B. If you have one capacitor, right, let us say C1. If you add one more capacitor in parallel, remember when we have parallel combination of capacitors, right, what is the formula? If you have another capacitor C2, parallel combination, what is the formula, guys? C equivalent is equal to what? C1 plus C2. Means what is going to happen? The equivalent capacitance value is going to be what, guys? Increasing. I mean, whatever capacitance you add, what is going to happen? Shri Vidya, you are also getting the answer as what? B. So whatever capacitance you add in parallel, right, what is going to happen? The C equivalent value is going to be what? Increasing. It will be more than C1 definitely. Means what? The denominator is going to increase. As a result, our omega naught value will be what? Resonant frequency value will be decreasing. Clear, guys? So what is the answer for this question? Third question, what must be the answer, guys? B must be the answer. And look at C and D also, right? What is C? C is saying that the iron core of the inductor should be removed. See, if you remove the iron core, right, remember what is the self-inductance L formula, guys? For a solenoid, we already covered it. What is the formula? Mu into N square A into L, where small n will be what? Number of turns per unit length. Mu is what? The permeability. If you have an iron core, right, mu value will be higher than mu naught. So means if you remove iron, means what is going to happen? L is going to decrease. We should at all increase L value. We should not decrease L value. If you decrease L value, means what is going to happen? The resonant frequency is going to be increasing. So this is not possible. This will not have any effect. Look at the option D. Dielectric in the capacitor should be removed. See, if you have a dielectric in the capacitor, right, what is the C dash formula? K into C naught, where C naught is the capacitance with the air. K is what? Dielectric constant. So if you remove the dielectric, means what is going to happen? Removing dielectric will be reducing capacitance, right? This also is not going to reduce the frequency. It is going to in fact what? Increase the frequency. Clear, guys? So what is the correct answer for this? Jivita, hi. What is the correct answer for this question, guys? The correct answer must be what? B. Okay. So we'll go to the next question, guys. See, ideally we should not be taking more than a minute. The moment the question is there on the frame, right, you should be able to give the answer in less than a minute. I might take some time to explain. Okay, look at this question, guys. An alternating voltage is given to us. What is alternating voltage formula? 200 root 2 sine 100 t volt. Okay, so if you compare this with the normal formula, what is the normal formula? V is equal to V naught sine omega t, like that. That is the normal formula, right? Then you can see what is the peak value of the voltage? 200 root 2. What is the omega value, guys? 100. So an alternating voltage is given as what? 200 root 2 sine 100 t is connected to 1 microfarad capacitor through an AC ammeter. Okay, the reading of the ammeter is, we need to find what is the reading of the ammeter. We need to find what, guys? We need to find what is the reading of the ammeter. Yes, guys. Fourth question. Remember, always any measuring instruments, right? They are going to give us which value? They are going to give us the value of IRMS. Any measuring instrument we are having, right, guys? They are going to give us what? The value of IRMS. So this circuit is what? What is this circuit, guys? This circuit has got just an AC source and fourth one, Trisha, you are saying B. Okay. So this is what? Just a capacitor circuit. We are having nothing else. We are just having what? Capacitor. So here we will talk about what? The capacitive reactance. We will talk about what, guys? Capacitive reactance. So check it, guys. Fourth one, what is the answer? So we know the peak value of voltage. Peak value of voltage by the capacitive reactance will give us what? It will give us the peak value of current. Peak value of current, we have to divide it by what? Root 2. I naught by root 2 will give us what, guys? IRMS. Check it, guys. Fourth one. First, what we have to find? We have to find the capacitive reactance. What is the capacitive reactance formula? 1 by omega naught into C, or omega into C. 1 by omega into C. What is the omega value? 100. C is what? 1 microfarad. So first we have to find the capacitive reactance, and from capacitive reactance we will find what? IRMS. From capacitive reactance we can find IRMS value. Check it, guys. So what is the first step? The equation given to us is what? V is equal to 200 root 2 sine 100t. Means from comparing with this the standard equation, what we are going to get? We will get what, guys? Karthikeyan, fourth B. Okay. V naught value, peak value of voltage is what? 200 root 2. Omega value is what? 100. What is the capacitive reactance, guys? We will indicate with which symbol? XC. Inductive reactance we will use what? XL. Okay. So capacitive reactance is what? 1 by omega C, right? 1 by omega is what? 100 into C is what? 1 microfarad means 10 power minus 6. So overall it is what? 10 power 4 ohms. Remember, both capacitive reactance and inductive reactance, right? They will have which unit? They will have the units of ohms. And once you get it right, we need to find the IRMS. How we can find IRMS? IRMS will be equal to what? We can straight away do this. VRMS by XC. VRMS is what? V naught by root 2 XC. So V naught is what? 200 root 2. Divide by root 2 into XC's value was what? 10 power 4. So root 2 is cancelled. What is the answer, guys? Some of us are able to tell the answer correctly. What is the answer? 200 by 10 power 4 means what? 200 into 10 power, sorry, 2 in 10 power minus 2 means what? 20 milliamperes. What is the answer, guys? 20 milliamperes. What we are doing in this question? First we are finding the capacitive reactance. And then what we are doing? IRMS is equal to what? VRMS by XC. That's it. It's a straight question kind of a thing, guys. Just we have one capacitor circuit. Okay. Others also check it. We must be getting the answer as what? 20 milliamperes. Madhumita, you are also getting the answer as what? 20 milliamperes. So we can have similar problems on just inductor circuit. In that case, what we will be doing? If you have just inductor circuit means you want to find the IRMS value, it will be equal to what? There VRMS by XL is going to come. We can have just capacitor circuit, just inductor circuit. Clear, guys? And what will be the XL value? Inductive reactance will be equal to what, guys? Omega into L. Capacitive reactance is what? 1 by omega C. Inductive reactance is what? Omega into L. So these formula we have to keep in mind, guys. Okay. Let's move to the next question. Fifth question. A 16 microfarad capacitor is charged to a 20 volt potential. So we have a capacitor of 16 microfarad. It is charged to what? 20 volt potential. The battery is then disconnected and a pure 40 millihenry. Guys, we have to be careful about these prefixes. What is the inductance value? 40 millihenry coil. is connected across the capacitor so that the LC oscillations are set up. So we are charging a capacitor, disconnecting it from the battery and connecting it across a pure inductor. So this is what LC oscillations are going to happen. The maximum current in the coil is what we need to find, guys. We need to find what is the maximum current in the coil. Check it, guys. How do we solve this question? When we are discharging the capacitor, right? Capacitor will be having some energy. What is the energy formula going to be, guys? Half CV square. Because capacitance is given and what is the battery to which it is connected is also given. We'll have the energy as what? Half CV square. Now this energy is going to be oscillating between the electrostatic energy form and then magnetic energy form. When we have this entire energy converted into the magnetic form, right, that is where you are going to be having the maximum current, because the energy stored in the inductor is going to be what, guys? Half L into the I square. So when this total electrostatic energy is converted into the magnetic form of energy, right, that current is basically the I max value. The corresponding current value will be what, guys? I max. So what we are going to do in this question, we will see first what is the energy of the capacitor when it is when it is basically disconnected, and then we are bringing it to connect to the inductor, and we equate. This is the maximum energy. This energy is going to be oscillating between the inductor and the capacitor. We see if the full energy is going to inductor side, that current will be the maximum current. And what is the formula for that? Half L I square. So C is given, V is given, L is given. We have to find the I max. Yes, guys, fifth question. Any answers? Fifth question, guys. Any answers you are able to get? Fifth, Asher John, you are saying B. B is what? 40 milliamperes. Okay. Any other responses, guys? So let's just get into the solution part of it. What is it? The energy stored in the capacitor part will be what, guys? Half CV square. That is going to be the maximum energy for these oscillations. Half into C is what? 16 microfarad, means 16 into 10 power minus 6 into V square, means what? 20 square. So this will be coming as what, guys? 3.2 in 10 power minus 3 joules. What is the value of this energy? 3.2 in 10 power minus 3 joules. So here we have to be careful about the prefix part of these units. Okay. Then look at the energy on the inductor side, guys. What is the energy stored in the inductor? Half L I square. Okay. And you want to have the maximum current, means we have to equate this to what? The maximum energy of the capacitor. So maximum energy of the inductor is what? Half L I max square. We are equating it to what? The maximum energy on the capacitor side. What do we do, guys? Half into L is what? 40 millihenry, means what? 40 in 10 power minus 3 into I square is equal to what? 3.2 in 10 power minus 3. So I square will be coming as what, guys? 2 into 3.2 by 40. We'll have to take a root of it. Okay, so if you take a root of it, then what is the value of I going to be coming as what, guys? 4 by 10 or 0.4 amperes. Check it, guys. What is the answer? What is the answer, guys? 0.4 amperes. Okay. So we have to be, these are like straight questions, guys, but we have to be careful about the number part. Okay. So here, right, 2 into 3.2 means by 40, right, we can multiply both the numerator and denominator by 10. So what we will get? 2 into 32 by 400. So 2 32s are what? 64, right? 64 by 400 means 4 16s are 400s are. So I square is what? 16 by 100, means I will be equal to what, guys? Root of 16 by 100 is what? 4 by 10. Okay, so we'll go to the next question, guys. This is the answer for the 5th question. Okay, look at the next question, 6th question. A resistor 500 ohms. What is the resistance value, guys? 500 ohms, and an inductance 0.5 Henry. So we have a resistor of 500 ohms and inductance of what? 0.5 Henry are in series. They basically are what? Series. So this is like what, guys? This is like an LR circuit, or we can say RL circuit. Okay, LR circuit or RL circuit. Okay, this is series with an AC which is given by 100 root 2 sine 1000 t. Means what is the V0 value? 100 root 2. What is the omega value? 1000. The power factor of the combination is, what do we need to find, guys? Power factor. So how do we find the power factor? Remember, what is the power factor formula, guys? Cos phi is the power factor, right? What is the cos phi formula? R by Z. So here it is a LR circuit, means what is it? Z will be root of R square plus XL the square. Z will be what, guys? Root of R square plus XL square, right? Now we have to do it. What is XL? R value is given to us. What is the R value, guys? 500 ohms. XL value we have to find out. What is the XL formula? Omega into L. Omega is what, guys? 1000 into L. What is L? 0.5 SI unit Henry, which is what again? 500. The SI unit of inductive reactance is also what, guys? 5 ohms. So R is 500, XL is also what, guys? 500. So look at this. Yes, guys, any answers for this one? 6th one, yeah. Trisha, you are saying A. Fine. Akash, you are also saying A. So what is it, guys? 500 by root of 500 square plus 500 square. Denominator is what? Root 2 times of 500. So cos phi value is what, guys? The power factor cos phi is what? 1 by root 2. Asher John, yeah. What is the answer for the power factor, guys? 1 by root 2. So what is the power factor formula? Cos phi is the power factor, right? Cos phi will be equal to what? R by Z. Clear, guys? 6th, you must be getting it as what? A. Okay. So we'll go on to the next question, guys. So these are some straight questions. We must be quick enough to get these answers. Let's look at the next one, guys. So this one, what is the answer? A is the answer, 1 by root 2. Okay, we'll go to the next one. This is based on the efficiency of the transformer. Look at this question, guys. A step down transformer is used on a 1000 volt line to deliver 20 amperes current at 120 volt. Means the secondary coil current is what? 20 amperes. Voltage is what? 120. Okay. If and primary coil, what is the voltage? 1000. If the efficiency of the transformer is what? 80%. What is the efficiency, guys? 80%. Means if you look at efficiency factor, right, what is it going to be? 0.8. The current drawn from the line is, means they are asking what is the primary coil current. When they say power current drawn from the line, means what? They are asking what is the primary coil current. Look at this, guys. 7th one is another straight question. It's a question based on what, guys? Efficiency. Efficiency means what? Power output by power input into 100. What is the efficiency, guys? Percentage efficiency of the transformer is what? Power output by power input into 100. So you have to use that formula. Power is what? V into I. Power is what, guys? V into I. Check the one, guys. 7th question, we must be able to get the answer. So we have to use the formula. Efficiency is equal to what? Power output by, or power in the secondary coil by power in the primary coil into 100, because we are talking in terms of what? Percentage of the efficiency. Power in any coil will be equal to what, guys? Current into voltage. Secondary coil, we have the current value as well as voltage. Primary coil, we are having voltage only, current is not there. That is what we have to find. Yes, guys, 7th question. 7th Jivita, you are saying A. So you are saying the current drawn from the line means the current drawn from the primary must be equal to what? 3 amperes. Okay. Check it guys, others also. So look at the formula guys. The power factor eta power factor will be equal to what? The power in the secondary coil by power in the primary coil. So ES into IS, E is what? The voltage in the secondary coil into current divided by EP into IP, that is the efficiency factor. Now efficiency factor here will be what? Since percentage is 80, factor will be equal to what? 80 by 100 or 0.8. Okay, is equal to what? 120 into 20. Voltage is 120 in the secondary coil, current is 20, divided by primary, the voltage is what? 1000 into IP, that is the current in the primary, that's what we have to find, is equal to what? 80 by 100. Cross multiply, we will get what guys? IP must be coming as what? 3 amperes. Check it guys, this is a straight question. So this formula we have to remember guys, it's an important one. So what is the efficiency factor? It will be equal to what? Power output by power input. And if we assume that there is no power loss at all, the efficiency factor will be equal to what? 1. If there is no power loss at all means the efficiency factor will be equal to what guys? 1. And even sometimes we can expect some theoretical questions on what are the reasons for the power loss. So you remember the reasons for the power loss guys. One is because of what? The improper winding, right? There will be some flux losses that might happen, and there will be some copper losses because of the heating of the copper coil. There will be some loss of the power or energy basically. So we can even have some questions on the reasons for the power loss. Okay, we'll go on to the next one guys. Look at this one. In an AC circuit, the current is given as what? This is the current function. What is the current function given as got guys? 5 sine 100t minus pi by 2. And the potential difference is given as what? 200 sine 100t. Then the power consumed is. So we have to find what guys? What is the power consumed? So they have given what? The current function they gave, and they have given the potential difference function or the voltage function they gave. What they are asking? They are asking what is the power consumed? 8D. Okay, Trisha, you are saying 8 is D. So you are saying the power consumed will be equal to what? 0. Okay. So check this question guys. This is a kind of straight question. The moment you see it, right? The moment you see this, one thing that will strike us is that if you see, the current is lagging by how much phase difference guys? Exactly pi by 2. So I is lagging. I is lagging by how much guys? Pi by 2. And for which kind of an circuit this happens? It happens for the inductor circuit. So for the inductor circuit, right, the current will be what? Lagging, or we can say voltage will be leading. We can say the other way, voltage is what? Leading by pi by 2. And if you have either an inductor circuit or a capacitor circuit or an LC circuit, either a pure inductor circuit or a pure capacitor or an LC circuit, right? For all of them, what is the average power value guys? What is the average power for all of them? It is going to be what? 0. Because all those circuits, right? Look at the power factor formula simply. What is the power factor guys? Cos phi is equal to what? R by Z, right? Will they have any resistance in that? They will not have any resistance. So power factor for all of them is equal to what guys? 0. So pure inductor, pure capacitor and LC circuits, right? The power factor for them will be equal to what guys? 0. So hence what is the answer for this question guys? 0. The average power consumed is equal to what guys? 0 for these three circuits, either inductor circuit or capacitor circuit or LC circuits. Okay guys, we'll move on to the next question. Look at this. The power factor of the circuit as shown in the figure. So we have a diagram given to us. In this diagram we have to find what? Power factor. So means what? We have to find what guys? Cos phi. We have to find the power factor. It's a straight question guys, formula question. What is the cos phi formula? Root of, so R by root of R square plus XL minus XC the whole square. What is the power factor formula, guys? Cos phi is equal to what? R by Z. R by Z means what? Root of R square plus XL minus XC the whole square. Okay. So here one thing we need to keep in mind, that normally what we have when we say LCR circuit means we have just one resistor, but we see here there is R1 and there is R2, and these two are happening to be in what? Series. The inductor coil is also having some resistance. What is the value of the resistance of the inductor coil, guys? R2, it is given as what? 40. So this R1 and R2 are in what? Series. So what is the R equivalent? Total R will be equal to what? 40 plus 40. It is going to be what, guys? 80. So that is the only thing we have to keep in mind. Okay, guys. So normally what we will be having, just we'll have one resistor, but here the inductor coil is also having what? Resistance. Then we should be taking, in place of R, we should be taking what? R equivalent. What is the equivalent resistance of the entire circuit, guys? 40 plus 40, because they are in series, right? 40 plus 40 will be equal to what? 80. Then XC value is given to us. What is XC value? 40. XL is also given. What is XL value? 100. Yes, guys. Ninth one, D you are saying. C. Akshay, you are saying C, and Shreya, you are saying D. Okay. Trisha, you are saying C. So, guys, it's a formula question, right? What we have to do? R. R is what? 80, right? 80 by root of 80 square plus. What is XL minus XC? 100 minus 40 is what, guys? 60. 60 square. So, you know, what is this? 80 square will be what? 6400. 60 square will be what? 3600. Totally it will be what? 10,000. Root 10,000 is what, guys? 100. So means what? 80 by 100. I think we got the answer, guys. What is the answer? It must be what? 0.8. Check it. Akash, you are getting B. Check it. No. So in this, what is the one change we have from the normal kind of problems? Here the inductor coil is also having what, guys? Resistance. So the equivalent resistance must be what? Since these two are in series, the equivalent resistance will be equal to what, guys? 80. 40 plus 40 in series means what? It is going to become what, guys? 80. So that is what we have to be careful. Clear, guys? I think yeah. So just check it, guys. What must be the answer? Answer will be what? Option C. Okay. We'll go to the next question, guys. This is an slightly different kind of question, and probably something that we will take a look at with a little bit more interest, because this is a parallel LCR combination. So here we can see the inductor, capacitor and resistor, all of them are in what? Parallel. Okay. So look at this question, guys. Maybe you can try this question, but I'll also explain this in detail. In the circuit shown, XL is equal to XC by 2 is equal to R. Means they are giving the relation between the inductive reactance, capacitive reactance and resistance value. The peak value of current I0 is, we have to find what is the peak value of current. So if you look at this, right, guys, maybe, you know, I'll just wait for some time so that you can try it out. So we need to find what the peak value of current. To find the peak value of current, right, we must first get the net impedance, because V0 by Z is going to give us what? I0, that we know. And if it is a series LCR means we know the Z formula. What is Z formula? Z will be equal to what? Root of R square plus XL minus XC the whole square. That we know in case of an series LCR. But this is what? Parallel LCR. So for a parallel LCR, how we are going to find the impedance value? So for a parallel LCR, if you look at it, right, what is the correlation between them? At any instant, if you see the potential drop across each of these components because they are in parallel. Here what will be the common thing between them? The common thing will be the potential drop. And how it is going to be common, if you look at each of these terminals, right? The terminal 1 and terminal 2, terminal 1, terminal 2, terminal 1, terminal 2, all of them are connected to the source basically. So the potential drop across all of them will be what? Same. And in that case, if you measure the current through inductor will be equal to what? V0 by XL. Current through the capacitor will be equal to what? V0 by XC. Current through resistor will be what? V0 by R. These are the current values. And if these are the current values, right, these currents will be definitely in different phases, because in an inductor we'll have a phase difference between the voltage and current. Capacitor also we have a phase difference between voltage and current. And resistor only the current and voltage will be in the same phase. So here if you want to look at what is the overall current drawn, we look at overall current drawn from the source. The overall current drawn, we have to apply the phase relation. So what will be the phase relation? The phase relation will be that if you see the overall current as V0 by Z, then that V0 by Z value will be equal to root of, here the IL and IC, they will be out of phase and they will have a phase difference of pi by 2 with what? IR. So the same relation will happen here, guys. What is it? V0 by Z, which is the overall current, will be equal to what? Root of IR square plus IL minus IC the whole square. What is IR? V0 by R. IL is what? V0 by XL. IC is what? V0 by XC. So if you take out V0 common and then cancel on both sides, right, what we are going to have is this formula. So this is the formula for finding the net impedance of an parallel LCR circuit. So maybe you can just make a note of the formula, guys. What is the formula? How we are getting it? If you have a parallel circuit, we are seeing what is the current across each component, and we are getting the value of overall current is equal to what? V0 by Z. Overall current is what? V0 by Z is equal to what? Root of IR square plus IL minus IC the whole square. And here on taking the V0 common out and then cancelling it, right, what we'll have is 1 by Z. This Z is the impedance. 1 by Z is equal to what, guys? So root of 1 by R square plus 1 by XC minus 1 by XL the whole square. So this is going to give us what, guys? The net impedance. This formula we have to remember. This formula is for what, guys? The parallel LCR combination. If at all we have a question on this, right, we must be ready to answer it. Okay. So now look at this, guys. First we'll find what is the Z value. So from the given relation, right, look at this. XL is equal to what? R only. XC is equal to 2R. XL is equal to R and XC will be equal to what, guys? 2R. So 1 by Z is equal to root of 1 by R square plus 1 by XC. In place of XC what we are keeping? 2R we are keeping. And in place of XL what we are keeping? R. 1 by 2R minus 1 by R the whole square. Okay. So finally what we are going to get? Root of 1 by R square plus this 1 by 2R minus 1 by R will be minus 1 by 2R. Square it means it will become what? 1 by 4R square. If you square it means it is going to become what, guys? 1 by 4R square. So inside the root what we will be having is 5 by 4R square. If you take the root out means root 5 by 2R. So what is the value of 1 by Z, guys? Root 5 by 2R. So from here Z value will be equal to what? Reciprocal 2R by root 5. What is Z value, guys? 2R by root 5. And once we get the Z value means we can find the I0. What is I0 value? V0 by Z, right? So V0 divided by Z. What is Z, guys? 2R by root 5. So the root 5 will go to the numerator. What is the peak value of current, guys? Root 5 into V0 by 2R. So here we have spent some time on the derivation part of it, guys. Maybe you can remember the formula. If we have a parallel LCR combination, right? What is the formula for the net impedance? 1 by Z is equal to root of 1 by R square plus 1 by XC minus XL the whole square. Okay, this formula we have to remember. And using this formula, next time if you have any question like this, right, we will be able to solve the question based upon this formula. And I even showed you how do we get the formula by using the current measurement. Okay, so what is the answer for this question, guys? 10. What must be the answer? A must be the answer. Okay, we'll go to the next question, guys. So that parallel LCR one, right, you just keep it in mind. So if at all there is a question on that, right, we must be ready to attempt it. Okay, look at the 11th question, guys. An AC voltage is applied to a resistance R and inductor L in series. Means what? This is what? RL series. If R and the inductive reactance are both equal to 3 ohms, means what they are saying? R value is equal to what? 3 ohms, and XL value is also equal to what, guys? 3 ohms. The phase difference between applied voltage and current in the circuit is, what do we need to find, guys? We need to find what is the phase difference between the applied voltage and the current. So this is what, guys? Simply RL circuit. In this we need to find what is the phase difference between the applied voltage and current value. Yes, guys, look at this question, 11th question. 11th B. Okay, Trisha, you are saying 11th is what? B. So if you have the RL circuit, right, guys, this is the current phase, imagine, and the voltage across the resistor will also be in the same phase, but voltage across the inductor, right, remember inductor, what is the property of the inductor? Voltage will be leading by how much? Pi by 2. The resultant, right, will be along this direction. This is the phi. Okay, so what is the value? This is what, guys? XL. This is what? R. So what is the formula, guys? What is the formula? 11th, Asher John, you are saying D. They are not asking, I mean, how can it be D? Because they are asking what, guys? The phase difference between the applied voltage and the current. This is what? RL circuit, right? So what is the formula, guys? What is the formula? Tan phi will be equal to what? XL by R. Tan phi is equal to what? XL by R. XL value is 3, R value is also 3. Means 3 by 3 will be what? 1. So if tan phi is 1, means phi will be equal to what, guys? Pi by 4. Tan phi is equal to 1 means what? Pi will be equal to pi by 4. So this is the RL circuit where the voltage will be leading. If you have RC circuit, right, we'll have just the reverse. So here current and voltage for the resistance will be in the same phase. The voltage in case of capacitor will be lagging by pi by 2. Here we'll have it in the other direction. This is XC, this is what? R. Here also what we'll have? Tan phi will be what? XC by R will be coming, but this will be what? In the other direction. The voltage will be lagging. In the LR, the voltage will be what? Leading. In the RC, the voltage will be what? Lagging. But the formulas will be similar. Clear, guys? So what is the answer for this? Option B is the answer. See, whenever we have a question, right, we must also be thinking, this is important while you are practicing questions, guys. You must also be thinking on what other kind of models of questions can be asked. Okay, we'll go to the next question, guys. 12th one. Look at this. In an LCR series, the series LCR, the voltage across each component L, C and R is 50 volts. Across each component, what is the voltage, guys? 50 volts is the voltage. Okay. Then the voltage across the LC combination will be. So voltage across each of the components, like say for example we are having what? First a resistor, then let us say we have an inductor, then we have capacitor. Voltage across each component. Here what is the voltage? 50 volt. Here what is the voltage? 50 volt. Here what is the voltage? 50 volt. Across each component, what is the voltage, guys? 50 volts. They are asking what is the voltage across the LC combination, means from here to here. Between these two, what is the potential difference or voltage, whatever we call it. That's what they are asking. Look at this, guys. 12th question. Any answers? Twelfth A, Trisha. Okay, guys, check it. No, it's a series LCR, right? Look at this. We have resistor, current and voltage will be in the same phase, and for the inductor, right, voltage will be leading by how much? Pi by 2, 50 volt. capacitor voltage will be lagging by pi by 2, 50 volt. So if you think of it like vectors, right, this is like what inductor is. If you think at like 50, I mean we can't use that vector notation here, but if you think of it, this is like what 50 j cap. What is this VC value? 50 into minus j cap. So what is the overall potential across the LC combination, guys? This plus this. How much it is going to be? So these two will be what, guys? Completely like out of phase, right? What is the overall value? Check it, guys. 50j plus minus 50j. What will be the answer, guys? It will be what? 0. It will be what, guys? 0. If somebody is asking, we know the VR value, VL value and VC value. They are asking what is the overall potential difference. You know what will be the overall potential difference? This VR is like what along I cap. The overall potential, this is the formula, guys. Look at this. It's like the vector kind of formula. It will be equal to what? Root of VR square plus VL minus VC the whole square. That is the overall potential difference across the LCR combination in series. So in this question, what is it, guys? Across L and C, what is the potential difference going to be? The voltage going to be? It will be what, guys? 0, because the 50 and minus 50 will be what? Adding up to 0. And remember this formula also, guys. In series LCR, right? What is the overall potential difference across these three components? It will be root of VR square plus VL minus VC the whole square. If you see, this is just similar to the vector kind of formula, right? VR is what? I cap. The resultant of these two will be what? In some other problem I am saying. In this problem, what is this? This and this will be equal. That's why they are cancelling each other. Some other problem, the net value will be what? VL minus VC or VC minus VL, whichever is higher. And that will be along the J cap. The resultant will be what? It's like root of X component square plus Y component square. Clear, guys? So this formula is important. The net voltage across the LCR in a series circuit. Okay, guys, we'll go on to the next question. Look at 13th question, guys. The self inductance of motor of an electric fan is 10 Henry. Means what? This is the L value. L value is given as what, guys? 10 Henry. In order to impart maximum power, what do we need? We need to impart the maximum power at 50 Hertz. It should be connected to a capacitance of. So what is the condition we are looking for, guys? We are looking for maximum power. And when we are going to get the maximum power? When we are going to get the maximum power, guys? Maximum power is going to come when we have the resonance condition. When the maximum power is going to come, guys? When we have the resonance condition. Why? Because look at the power factor formula. What is the power factor formula, guys? R by Z means what? R by root of R square plus XL minus XC the whole square. We want to have the power factor maximum means what? This XL and XC should cancel each other. That will happen when we have the resonance condition. So here we must be looking at the resonance condition. And for that we need to see what is the capacitance value required. Approximately we have to tell what is the capacitance value required. What is the condition, guys? Omega square should be equal to what? 1 by LC. That is the condition for resonance, right? What is the condition for resonance? Omega square should be equal to what? 1 by LC. From here we want C means C will be equal to what? C will be equal to what, guys? 1 by omega square into L. This is the formula. The capacitance value required is equal to what, guys? 1 by omega square into L. This formula we have to use. Check it, guys. 13th A. Shreya, you are saying 13th is what? A. Okay. So approximately, guys, 1 by omega square. Omega will be equal to what? 2 pi into frequency. Don't forget that. Omega will be equal to what, guys? 2 pi into frequency. Omega is what, guys? 2 pi into frequency. Frequency is given to us. What is the frequency given to us? 50 Hertz is the frequency. Frequency is given as what, guys? 50 Hertz. L is given as what? 10 Henry. Using that we have to find out. Check it, guys. The answer she is saying is 1 microfarad. So if you further simplify it, right, what it is going to come as 1 by omega will be what, 2 pi into frequency, right? So we'll have 4 pi square f square into L. 2 pi into frequency, square will come, means what, 4 pi square f square into L. Okay. Check it, guys. Most of us are saying what? Option A. Some of us are saying option C. Okay. So what is the answer for this question, guys? Option A. The capacitance value rate should be equal to what? Approximately 1 microfarad. The value must be coming as, guys, 1 microfarad. Check it again. So here the basic concept you have to remember is what, guys? If you want to have maximum power, means we must be having what? Resonance condition. That is the thing. And accordingly we have to find out what is the frequency required over there. Okay. Check it, guys. I am not sure if you are using calculators while solving it. Ideally we should not be, and we should be able to solve this question in at least 1.5 minutes to 2 minutes without using the calculator part. Okay. Others also check it, guys. Only some of you are able to get the answer, I guess. Okay. So what must be the answer? Note down the answer. It must be what? 1 microfarad. But remember the condition, that is important. In some other question also, if you are having the same situation, right, we must be able to use it. Okay, guys. We'll go to the next question. Look at the next question, guys. There is another interesting question on the LC oscillations. Even if we look at the sum of previous years, right, we do have questions like a good number of them have come from the LC oscillations. In an oscillating LC circuit, the maximum charge on the capacitor is what? Q. What is the maximum charge on the capacitor, guys? Q. The charge on the capacitor when energy is stored equally between the electric and magnetic fields. So what do we need to find? We need to find what is the charge on the capacitor when the energy stored is equally split between the electric and magnetic fields. See, first of all, what they are saying, maximum charge in the capacitor is what? Capital Q. 14th question, guys. Maximum charge in the capacitor is what? Capital Q. If we say C is the capacitance, if we say what? C is the capacitance value of it, then the maximum energy will be equal to what? Capital Q square by 2C, because this is corresponding to what? Maximum charge on the capacitor, means that is when the total energy will be stored as what? The electrostatic potential energy. Okay. And if in some other instant the charge is becoming, let us say, small q, the charge is becoming what? Small q. In that case, we are looking at what condition? The energy to be equally split between electric and magnetic field, means the energy will be half of this Emax. Correct. So the energy in this case when the charge is small q will be what? Small q square by 2c. That is the energy in this particular condition. This energy we are saying is equal to what? Half of Emax. Means it is equal to what? Half of q square by 2c. 2c is cancelled. Q will be equal to what, guys? We'll take a root on both sides. 1 by root 2 into capital Q. What is the answer for this, guys? 14th. The value must be equal to what? Capital Q by root 2 or 1 by root 2 into capital Q. What is the condition we are doing? When we say that maximum charge on the capacitor is capital Q, that is basically the situation where entire energy is stored in the electrostatic energy form, which is Q square by 2C. After some time, let us say the charge is what? Small q, where the energy is equally split. Equally split means what? The energy in this particular case will be equal to what? Half of Emax. And in this case, what is energy? Charge at that time, which is small q square divided by 2c. Equate both the formulae, we will get what? Small q value. How much is the small q value coming as, guys? It must be coming as what? capital Q divided by root 2. So this is another model of question on the LC oscillations. Okay guys, Karthikeyan, you are also able to get the answer. So check, we must be able to get the answers. Okay, so it's a straight question only guys, not much complication. We'll go to the next question. This is the 15th question. A 50 Hertz AC source of 20 volt. What is the voltage of the source guys? Voltage is what? 20, and frequency is what? 50 Hertz. Okay, connected across R and C as shown in the figure. So we have a resistor, we have a capacitor. The voltage across a resistor is what? 12 volt. What is the voltage across the resistor guys? 12 volt. We need to find what is the voltage across the capacitor. What do we need to find guys? We need to find what is the voltage across the capacitor. We are given voltage across the resistor. We have the source voltage, means what? The total voltage drop is what? 20 volt. We need to find what is the voltage across the capacitor. Look at this question guys, 15th question. We have to find what is the voltage across the capacitor. Previously only while we are discussing some other problem, I have told this. If you look at the voltage on resistor, it is in the same phase as current. Inductor, if it is there, means voltage will be what? Leading. Capacitor, voltage will be what? Lagging. So here there is no inductor, this part is not there. So the overall voltage V will be equal to what? Root of VR square plus VC square. What is the overall voltage value? Source voltage 20. 20 is equal to what? Root of VR square. What is VR? 12 square plus VC square. We'll square on both sides. 400 is equal to what? 144 plus VC square. Means from here VC square will be equal to what? 256. Means VC will be equal to what? What is root 256 guys? It will be what? 16 volts. What is the answer? 16 volts we must be getting it as. So clear guys? How do we relate the voltage values? So voltage drop across the resistor and voltage drop across the capacitor, right? How we are going to use it to find overall voltage in the circuit? V will be equal to what? Root of VR square plus VC square. And I already told you the series LCR, right? What is the overall voltage drop in series LCR? VR square plus VL minus VC the whole square. That will be for the series LCR. Here we don't have any inductor, we have just what? Resistor and capacitor. Clear guys? Okay. So we'll go on to the next question. 16th one. An inductor coil of inductance L is cut into two equal parts. The inductor coil is basically cut into how many parts guys? Two equal parts. Both parts are connected in parallel. We cut it in two equal parts and we connect them into what? Parallel. Now what is the net inductance? So what we have an inductor coil basically like this. We cut this into two parts. Part 1 and part 2. Now we put them in what? Parallel. They are asking what is the net inductance. So initially what is the overall value? L. For the overall coil, what is the inductance value? L. We have to find when we cut it and then put them in parallel. We cut this and we are keeping them in what guys? Parallel. What is the net inductance value? That's the question. 16th, Trisha, you are saying what? C. Okay, Shri, they are also saying what? C. Guys, remember when we divide an inductor into two parts like this, right? Each part is going to have how much inductance? L by 2, L by 2. Remember, how do we easily remember this? Inductor is just like what? Resistor. This is L by 2, this is L by 2. When we put a series, these two parts are like what? Series, right? L by 2 plus L by 2 is what? L. So when you have an inductor, if you divide this into three equal parts like this, three equal parts, then each part is going to be having what? L by 3, L by 3, L by 3. So totally when we add it, it is going to be what? L. So each part is what guys? L by 2, L by 2. Now L by 2 and L by 2 are in what? Parallel. So we have to find the equivalent of both of them. what is the L equivalent formula? It will be what, guys? L1 L2 by L1 plus L2, like the way we have in the normal resistances, right? When they are in parallel, what is the equivalent value? R1 R2 by R1 plus R2, same way. So means what? L by 2 into L by 2 by L by 2 plus L by 2 is what? L. So what is it, guys? L by 4. That is the equivalent inductance. What is the answer for this question, guys? 16th question, it must be what? Option C, which is L by 4. Okay. Clear, guys? We'll look at the next question, 17th question. In a circuit, this is another theoretical question, guys. We must be able to answer this easily. In a circuit, the current lags behind the voltage. In a circuit, current is lagging behind the voltage by a phase difference of how much? Pi by 2. Current is lagging behind the voltage by phase difference of voltage pi by 2. The circuit will contain which of the following? Yes, guys, it's a straight theoretical question. We have been discussing about this idea for quite some time. The current is lagging behind the voltage. So if you have a current like this, the current is lagging behind voltage by pi by 2. Other way to say it is what? Voltage is leading by what? Pi by 2. Either ways. So what is this circuit, guys? 16th. Okay, so we'll move on to the 17th. We are in 17th question now, guys. So what is the circuit? Is it only resistor? Is it only capacitor? Is it R and C, or is it only L? 17th, what is the answer, guys? D. What is it? It's only inductor circuit. When you have inductor, voltage will be what, guys? Leading by pi by 2, or current will be lagging by pi by 2. Clear, guys? Okay, Karthikeyan, inductor. Fine. Okay. So these are the kind of questions sometimes we may be getting. We must be able to clearly give the answer, because in the hurry of the exam environment, right, we might be just getting off the track. We might even get confused as to thinking. So we need to understand the two basic principles, guys. What is it? If you have a current, whatever is the phase of current, resistor voltage will be same thing. Inductor, it will be leading by what? Pi by 2. Capacitor will be lagging by pi by 2. So this we have to always remember. Okay, guys, we'll go to the next question. In LCR series circuit, it is connected to a source of AC at resonance. Means what is the condition we are having? We are having the resonance condition. Okay. The applied voltage and the current flowing through the circuit will have a phase difference of. Means we are sitting in the resonance condition. So we are in the resonance condition, and we need to talk about what is the phase difference between what? The applied voltage V and current through the circuit. Yes, guys, we have to find the phase difference between the applied voltage V and the current. (18th) D. Okay, so means what? You are saying phase difference will be what? 0. So in resonance, right, guys, what will be the phase difference between current and voltage? It will be what? 0. And that is why we will have the power to be what? Maximum. So how do we know? Look at the cos phi power factor formula, R by Z. In resonance condition, Z is equal to what? R, right? So cos phi is 1, means phi will be equal to what? 0. So in resonance condition, the power factor value will be equal to what, guys? 1. And the phase difference between the applied voltage and current will be equal to what? 1. Why? Because the net impedance will be equal to what? Just resistance value. In resonance condition, net impedance value will be equal to what, guys? Just resistance. Clear? Asharjan, you are saying C. Think about it, right? Resonance condition. Resonance condition means what? The net impedance is equal to just resistance part. Means power factor is equal to 1. So phi must be equal to what? 0 degrees. Okay. Check it, guys. So these kind of, some simple theoretical analysis questions also we must be careful. Okay. So we'll go to the next question, guys. 19th one. An AC voltmeter reads 20 volt across a resistor and 30 volt across inductor, and 15 volt across capacitor. So we have a voltmeter which is taken to measure the voltage across resistor. Means what? This is VR value. 30 volt across inductor means what, guys? This is VL. 15 volt across the capacitor means what? This is VC. In LCR series circuit, what we have is what? We have a resistor, then we have an inductor, then we have a capacitor. These are all what? In series. In this case, the supply voltage will be, means what is the supply voltage? Guys, already we have this formula discussed. What is the supply voltage formula going to be, guys? V is equal to what? Root of VR square plus VL minus VC the whole square. V is equal to what, guys? Supply voltage formula is what, guys? Root of VR square. Remember, know what we are discussing. If there is a current phase, VR will be in the same phase. VL will be leading by pi by 2. VC will be lagging by pi by 2. So as a vector, we can think of it like what? This is along I cap. This is along what? J cap. This is along what? Minus J cap. So the net resultant will be equal to what, guys? Including the phase of them, it will be root of VR square plus VL minus VC the whole square. 19th D you are saying. Okay. Sri Vidya. Karthikeyan. 19th D. Trisha, you are also saying 19th D. Okay. What is the answer, guys? Root of VR square plus VL minus VC the whole square means what? Root of VR square means what? 20 square, 400 plus VL minus VC. 30 minus 15 is what? 15. 15 square is what? 225. So root 400 plus 225 is what, guys? 625. What is root 625? 25 volt. What is root 625, guys? It will be 25 volt. Okay. So we'll come to the 20th question, guys. Look at this. A hot wire ammeter reads 15 amperes. And remember, we always kept on telling that, if you have any measuring instrument, the measuring instrument is going to be giving us what? RMS values. If you say current means it is going to give us what? IRMS. If you talk about voltage means it is going to give us what? VRMS. Okay. Hot wire ammeter is giving us what, guys? 15 amperes. The peak value of current is, we have to find what, guys? It's a straight question. We have to find the peak value of current. So IRMS is given to us was what? 15 amperes. We have to find what? I naught. I naught will be equal to what, guys? What is the answer for the 20th question? What is the relation? I naught is equal to what? Root 2 into IRMS. Because what is the IRMS value? IRMS value is equal to what, guys? I naught by root 2. Okay. So anyway, I naught value we are looking for, right? What is I naught value? Root 2 into IRMS. 20th question A, correct. Okay, so root 2 into 15 amperes. What is the answer, guys? A must be the answer. Okay. So broadly, guys, in terms of the alternating current, you try to look at the series LCR problems and look at the formula related to the quality factor, the resonance condition, and then LC oscillations part of it. And even take a look at how do we find the overall potential or voltage drop in that LCR, or even if you have LR, RC and LC circuits, and the power factor calculations and net impedance calculations. So these are the things that we need to be looking at. Okay, and as such, if you have seen the problem that we solved today, right, we have solved like good number of models of various types of questions. So broadly, you try to focus your preparation along these lines, and in the next class of physics, right, which is tomorrow, we will be looking at electromagnetic waves. That's another straight theoretical, kind of a chapter, except one formula of the modified Ampere law. So that's only one formula we have where we can expect some numericals. Otherwise, it is mostly theoretical kind of a chapter. So tomorrow we'll see the electromagnetic waves.